Hey everyone, welcome back. So today we're going to be solving Leetcode 50, power of x comma n. This is a medium level problem and I'll be solving it in Java, but actually the solution is language independent. So whatever language you're in, this approach would apply to all those languages. Okay, and yeah, this is a very interesting problem with a very interesting approach, and we're gonna go through the optimized approach. Okay, now the problem statement is very simple. You're just given x and n, and you have to find out x bar n. Right now, some might be thinking, okay, why is this a medium problem? Right? Because you can just do, you can use an inbuilt function, or you can, iterate through the entire power and then keep adding it or multiplying it to the result. Right? If you're going to use an inbuilt function, that is wrong. Because why? Because the approach that we are going to achieve today is how the inbuilt function is built, right? So whenever someone does math dot power of something, the result that you get is the same as the question's statement, right? But how is this working? We don't know. Today the problem that we are solving is how this particular inbuilt function is built on. Okay, we're gonna understand how it's built on. It's of course not just iterating through the entire power and then figuring out the answer, because that would not be efficient because of the constraints that we're gonna look into. But yeah, we can't use the math power function because we are not supposed to be using inbuilt function, and we have to figure out a way to do it. So what we're going to do is we're going to implement this inbuilt function. Okay. And the second thing is, why not we iterate through the entire array, entire power, and figure out the answer, right? What we can do is we can just say until y power is not equal to 0, and what I'll be doing is I'll take an answer variable which will be answer into the value x, or whatever it is, x, and then I'll just reduce my power. Can I do this? Yes, you can do this, but let's look at the constraints. Look at the constraints. It's minus 2 power 31 to 2 power 31 minus 1. This is a huge number. On the worst case, so the thing is, whenever you cross more than 10 power 9 iterations, right, you'll start getting a TLE, because that is how your online editors are built, right? It at max, on the worst case, it can process 10 power 9 instructions. If not, it's gonna throw your TLE. With the constraint of 2 power 31 minus 1, of course you cannot process this because it's very huge. So this time complexity will be nothing but O of n, where n is the power, because you're iterating through the entire power. Now we need to figure out a solution which is optimized, which is better than this. What can be the solution? I mean, what can be the complexity? Can we say O of login would be a viable complexity? Of course we can, right? If you have to optimize O of n, the next optimal solution that you can achieve is O of login, and that's exactly what we're going to be doing now. Okay, now let's look into the intuition. Okay, now let's take a simple example of 2 power 4. Okay, 2 power 4, can I write it as let's break it down. It'll be 2 into 2 into 2 into 2. This is nothing but 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. Okay, now this is our value. Okay, and this is exactly what we have to achieve. Okay, let's make some observation over here. Can I write 2 power 4 as 2 into 2 into 2 into 2? That's exactly what we did over here as well, right? Yeah. But can I write this in a better way? Can I write 2 into 2 into 2 into 2 a better way? I can, right? Can I group these two? I can do that too. So this will be 2 power 2 into 2 power 2. Won't this give me the same answer? Yes, it will. Okay. Now you can say, hey Siddharth, this is okay for a even number. What about an odd number? 2 power 5. How can you write 2 power 5? You write it as 2 into 2 into 2 into 2 into 2. So if you see, only this 2 is an extra. Only this 2 is an extra, right? Whereas these 2's are the same as this one, right? So if I use the same, if I substitute this one over here, one will be 2 power 2 into 2 power 2 into 2. Makes sense? Yeah. So I can say that when power percentage 2 equals to 0, I can write my answer as answer into answer. Okay. When power percentage 2 is not equal to 0, I can write it as answer into my num. Num is nothing but, in our case, it's 2. Makes sense? Right. This is exactly the approach that we're going to be using today. And with this is where we'll form our solution. Okay. Now, let's not think of this in a iterative way. Let's think of this in a recursive way. Okay. Because recursion is such a beautiful topic, such a powerful topic. Let's think about this in a recursive way so that, we will be able to achieve the solution without using any loops. Okay. Let's do some functional programming. Okay. Now, what I'm saying is, I will go from 4. Our example was power was 4 and the value was 2, right? What I'm saying is, I'll go from 4 to 0, okay, by dividing it by 2. So 4 will be 4 by 2, and then 4 by 4, and then 0. Okay, all I'm doing is I'm just dividing it by 2 every time, right? And 0, right? This is what I'll be doing. Now let's write this in a recursive way. So for a recursive solution, what do we need? We need 2 things. One is the base case. Base case is where a function will break. A function call will break. Okay. And the second thing, that is your main logic. Okay. By looking at this, can we say what our base case would be? It's very simple. Our base case would be over here. Okay. So now I know I need to do something when I get 0. What do I need to do? What value do I need to return when I reach 0? I'll simply return 1. Make sense? I'll simply return 1. Why? Because 2 power 0 is 1, or anything power 0 is 1. So I'll just return 1. That is our base case. Base case is done now. What about our main logic? Main logic is where we will write how it should be multiplied when the value is even, how it should be multiplied when the value is odd. Okay. So let me write the approach, and then let's go through the recursive stack calls, and then you will get a very good idea on how it's working. Okay. So what I'm saying is, let me call this as int recursion of my my power. This is a pseudocode, okay? This is not the actual code. This is a pseudocode. Okay, power, and this will be my value, and this will be my answer. Let's take 3 variables over here. Okay, so let's write the base case. Can I say that my base case would be when if my power is 0, then I'm going to return 1. This is my base case. That's exactly what we saw over here. When my power, this is nothing but your power, right? This is nothing but your power. So whenever my power is becoming 0, I'm returning 1. Okay. Now coming to the main logic. Okay. What will be in our main logic? Okay. let me write it down, then I will explain you how it's working so that you get a very strong idea. So I'll be calling recursion of power by 2, and this will be my value and this will be my answer. Okay, and if my power by 2 equals to 0, then here is where I'll be return answer into answer. Okay, else I'll just return answer into 1, sorry, not 1, into the value. Okay, perfect. So let me break this over here, and then okay. Now let's understand what's happening. Okay, now let's take an example, the same example, 2 power 4. Okay, how am I writing 2 power 4? So initially this will be a parent call, recursion of power is 4, value is 2, and my answer is, let's say, 1. Let's take it as 1. Okay, this will be called. Let me write this as my parent call. Okay, now what will happen? Yeah, 4. Now what will happen is, it'll come here, it'll check if it'll come here, it'll check if my power is 0, which is not, then it'll go over here. Now what will happen is, another recursive call will be made, answer equals to recursion of 4, power by 2, right? 2, 2, 1. Okay, for which power value is it going to? For power 4, right? When power is 4 is when I'm doing power by 2. So the next recursion call is 2, 2, 1, when the power value is 4. Make sense? Right. Now this will come down. Okay, this will be answer. Okay, this will come down, I'll check. Okay, is my power 0? No, it's not. So I'll have to make a recursive call again. Recursion of 2, sorry, this is the first, is the power value, right? 2, 1, 2, 1. For which value? This is where power is 2. This is where my power is 2. Okay, now I'll come down again. Now my answer will be recursion of okay for power value 2. Okay, what is 1 by 2? 0, 2, 1. It'll come down over here. You'll see. Okay, now my power value is 0. Okay, which means that I have achieved the base condition. Now I have to return the value. Let me do the same. I'm going to return the value. So what I'm going to do is, this is going to come down, and this is going to return 1. Right? So now my answer. Okay, wait. I didn't write the power value over here. What is the power value for which you're calling this particular recursion? 1, because 1 by 2 is 0, and that's why you're calling. Okay. Now I'm returning the answer over here. So I've returned 1, right? So my recursive call, this is a call that I made. So this has received 1. Okay. Now it will come down. I just told you the entire logic, right? Over here, this will follow this particular logic. So what it'll do, it'll check what is the power. What is my power? 1. It's odd. So what I'll have to do, I'll have to return 1 into 2. Right? I'll have to return 1 into 2 to my next call. So what will this return? 1 into 2 over here. So this will be 2. Perfect. Okay. Now I have received 2. After receiving 2, what will happen is, this will come down. This is exactly what will happen in stack, but I'm just showing it to you in a more visual way. Okay. Now this will come down. Okay. My this has returned me 2. My answer is 2 now, right? Because I've assigned answer as 2. Now what will it do? It'll check the power. What is the power over here? Oh, sorry. It won't return back over here. It'll return back over here. okay, and then this will return back 2. Now I'll come down. My answer is 2. What is my power? My power is 2, which means that it's even. So I'll just do 2 into 2, which is 4. Okay, now my answer is 4. Now this function has been executed. These two will get evicted out of stack, and what will happen is, this will get evicted out of stack after it replies back to this function with 4, and this is already evicted out of stack. Perfect. Okay, now I've received 4. Okay, now I've received 4. What is my power over here? Power is 4. So this will come down. By coming down, I mean this is where I'm calculating the answer, and then I'm coming down, right? That's exactly what I'm showing over here. So my answer is 4. So what am I doing here? If it's even, I'm just doing 4 cross 4, 60. So I've received 60. Now I'll return back to my parent call with 60. Right? Makes sense? So this is how our approach is working. Now what is the time complexity? Time complexity is nothing but log of time complexity is nothing but O of log of the power, which is nothing but n. Because every time you're dividing it by 2 until it reaches 0. So it becomes by 2 and then by 4 until it becomes 0. So our time complexity will be O of log n. Okay. Here one more thing is that here it's given that the number is negative. Okay. If it's 2 power minus 3, I can write it as 2 power 3. Simple. So whenever I have a negative value, all I'll do is I'll calculate the same thing. When I'm returning the answer, I'll just return it as 1 by 2 power 1 by the answer. Okay. Perfect. Now that we've got the solution, let's code it up. Let's see how it works. Okay. Here it's double. We don't have to worry about that. We'll just typecast it to double, or we'll consider our answer as double. Okay. Now, perfect. Now I'll just write my recursive call. Public. This will also return double only. Recursion of. Okay, I'll take it as a better. Okay, double. Value, comma, int n, right? So this is nothing but the power, int power, and then my what would be my answer? My answer would also be double answer. Okay, let me minimize this. Okay, double is the answer. Perfect. Now I'm gonna put this. Okay, now let's write a base condition. Base condition. Okay. If my power equals to 0, then I'm just gonna have to return 1. Okay. Else my double answer would be recursion of what is my value? My value would be val, the same, and then my power would be power by 2, and then my answer would be answer. Okay. Okay. Now if my answer, okay, after this is done, what I'll do is, if my power %2 equals to 0, what I'm doing is I'm return answer cross answer, that's it. Else I'll return answer cross my value. Okay, done. Did we miss anything? No. Okay, perfect. Now this is my recursive call. Let's write my condition over here. Okay, let me call the recursion function. So let me have the value as double. final answer equals to recursion of value is nothing but x, power is nothing but n, and my answer is, I'll keep it as 1 for now. 1.0. No, I'll just keep it as 1. But with this, no, I'll just keep it as 1. Okay. Now my final answer is 1. If my x is less than 0, then I'm gonna have to return 1 by final answer, else I'll just return my final answer. Okay, perfect. Let's run it and see, and let's see if any error occurs. Okay, variable answer is already declared. Okay, it's already declared, right? I don't have to see this. Okay, I got a wrong value. Expected is okay, maybe I need to double off. Okay, I think this will work. I'm typecasting it to double. Okay, finance is double only, right? 001 by 00. Okay, I think I need to be taking math dot absolute value of n over here. Then I need to iterate through the solution. Okay, now let me run this. Okay, 3 still came wrong because n is -2. Okay, okay, you know what, there are some things over here that I need to check. Okay, x is less than 0, then I'm going to be returning double of, okay, yeah, sorry guys, I had to fix this offline because of the constraints over here. It's that x can also be less than 0 and n can also be less than 0, so that's exactly what I've handled over here. So if n is less than 0, I'm checking if x is less than 0, right? If both of them are less than 0, in that case, for example, you have -2 power -3. So -2 power -3, -2 power -3, right? So -2 power if x is also less than 0, if n percentage 2 equals to 0, meaning that you have something like this, right? My x value is 2 and my n value is -2 and my n value is also -2, so it'll be -2 power -2, right? So this will just be nothing but 1 by 2 power 2. Okay. What is power -3? 2 power 1 into 2 power 1 into 2 power 1, right? Minus, will give me -3. Okay, and that's exactly what I'm doing over here. 1 by 2 power 2. You see, 1 by answer. Else it's -1 by if n percentage 2 is not equal to 0. So what is 2 power -3? Can it be written as okay? So let me just explain this to you. See, 2 power, let's take 2 power -2, okay, which is over here, wherein I'm checking if my both x and n and x both are less than 0. It is less than 0, so I'm checking if n percentage 2 is 0, which is 2 percentage 2, it is 0. So what I'm doing is I'm just returning, okay, I'm just returning 1 by answer, so nothing but 1 by 4. Okay, why am I doing this? Because it is a n percentage 2 is the even value. So when you do minus 2 power minus 2 into minus 2 power 1 into minus 2 power 1, you get it as plus 2 power minus 1, which is nothing but 2 power minus 2, which is nothing but 1 by 4. But in the same case, let's consider this as minus 2 power minus 3, will be nothing but 1 by answer. Okay, wait, this can be written as minus 2 power minus 1 into minus 2 power minus 1 into minus 2 power minus 1, right? So this one will become equal, wherein you will get this as this one will become equal, where you get these as 2 power minus 2 into minus 2 power minus 1. So this will be nothing but minus 2 power minus 3. So I can write it as minus 1 by 2 power 3, and that's exactly what I've done, minus 1 by, okay. Else I'm just returning 1 by answer. Else is for what? If x is greater than 0. So basically if it's 2 power minus 2 power, if x is greater than 0, right? If x is greater than 0 but n is less than 0, yeah. So if let's say that the answer value is 2 power minus 3, this is positive, this is negative, so I'll just return this as 1 by 2 power 3, and that's exactly what I've done over here. Okay, similarly, else if x is less than 0, okay, what I'm checking here is if n is less than 0, I'm checking if x is less than 0. Okay, x is nothing but my value. Okay, let's say minus 2 power 3. Okay, again I'm checking minus 2 power 3 can be written as minus 2 power 1 into 2 power 1 into 2 power minus 2 power 1 into minus 2 power 1. This will not be nothing but minus 2 power 3 only, right? But in this case of minus 2 power 2, this can be written as minus 2 power 1 into minus 2 power 1 to give me 2 power 2 positive value. N percentage 2 equals to 0, I'm returning the answer, else I'm returning minus 1 of the answer. That's exactly what I've done. So let's submit it. It's just that I had a few confusion because I solved this problem long back. So I just had to go through the problem again and then try to resolve every error that I got, and yeah. But now I think it looks fine. Let's submit it and see the answer. Perfect. Okay, let's analyze the complexity. We got a complexity of log of n. I hope you understood the solution. Thank you so much for watching. Stay consistent. Thank you.